This video is going to detail salts and solubility. So I have two test tubes here, one that has nickel sulfate in it and one that has sodium carbonate in it. You can see that without water that they look like crystals. Nickel sulfate is this nice bluish green color. Sodium carbonate also looks crystally and it is a white color. Salts are made up of two parts. They're made up of a metal ion, so that would be our nickel and our sodium, as well as a non-metal ion, and in this case that would be our sulfate and our carbonate. So if we were to write these as salt formulas, we would have nickel, which is represented by Ni, and a sulfate attached to it. And my sodium carbonate, that's Na with CO3. So these are my salt formulas. These two salts are soluble. I know that because of the periodic table. So if we go on to the back, we can find nickel with sulfate is a yes, meaning it'll dissolve in water, as well as sodium and carbonate is a yes, it will dissolve in water. So I'd like to show you a couple different ways to visualize what it means to be soluble. First, let's look at just what physically happens when something is soluble. Here again is my nickel sulfate. Soluble means that if I add water to it, and I mix it, you can see here that the salt is dissolved. There's no longer salt crystals in here, and it's transparent, which means I can see through it. It maintains its color because nickel has color, but this is a soluble salt. If it were insoluble, it wouldn't dissolve like this. I've done the same thing for my sodium carbonate, but you can see here that this has no color because white salts will dissolve and have no color. It's transparent, I can see right through it, and it's colorless. This means that this salt is soluble. So on a physical level, we can see what solubility looks like. But what does that look like on a molecular level? What has actually happened to the atoms? So like I was saying here, our nickel sulfate is made up of nickel ions and sulfate ions. When nickel sulfate is put into water, these ions will separate from each other. And when they separate, they will have a charge. Nickel has a 2+ charge, which is something we can find on our periodic table. Right here, nickel 2+. And sulfate will have a 2- charge. Again, that can be found on your periodic table. This is what it means to be soluble, that my salt here, when I add water to it, will split apart into its ions. If we were to look at this like a beaker, or my test tube, we have some water. It means nickel 2+ will be floating around, and sulfate 2- will also be floating around separate from each other. If I were to evaporate all the water out, it would go back to its salty form as nickel sulfate. This salt forms because the positive on the nickel is attracted to the negative on the sulfate. The same thing happens with sodium carbonate. Sodium carbonate, when put into water, will separate into 2 sodium ions, because I had 2 here, and 1 carbonate ion. These will be separate from each other in solution. That's what it means to be soluble. So now let's look at IC 2020 as a way to also understand solubility. So I'm going to choose a soluble salt. And when they are not dissolved in water, I can make a lattice, which is a large crystal, with many of these plus and minus ions. And if I press play, they are attracted to each other in such a way that they'll stick together. So until something else is added into this, these will stay together. This is what the salt looks like. The salt is visible to your eyeballs because there's many ions all attracted to each other, stuck together. You can see that the positives and the negatives are attracted to each other. And I can just keep going and making this lattice. However, when I add some water in, the water will break them apart. So add some water in. And if I pause it, you can see that these ions are no longer stuck together. They are separated apart because the water came in and broke them all apart. That is what it means to be soluble, when the negatives and positives in a salt are broken apart. So I can turn it up a little bit. And for the most part, all of my ions are broken apart. So when we put it into water in the lab, there's tons and tons and tons and tons of water that get in between all of the ions that are in solution. You can see that all of my ions are broken apart. That's because water has the ability to break all these ions apart. That's what it means to be soluble. Let's look at what this means in terms of our Lego pieces, because our Lego pieces are modeling what's happening to the molecules. So let's start with our nickel sulfate. Here I have nickel sulfate as a salt. We can see that the sulfate is made up of these red, orange, and the capper pieces, and my nickel is the piece on the bottom. So when I stick this salt into water, it will break apart into its two component parts. The sulfate is going to stay together because those are bound by something other than what's holding this together. So what's holding my salt together here is my attraction between the plus charge and the negative charge. What's holding my sulfate together is something different. So the S and the 4 oxygens, those will stay together, but it will split apart from my nickel ion. The same thing is going to happen for my sodium carbonate. Here I have carbonate on the top. It's made of a carbon and 3 oxygens. Again, that polyatomic ion is held together by something different than what's holding together our sodium and our carbonates. Our sodium and our carbonates are held together in a salt because they have attractive forces between the negative and the positive. But when I put it into water, the water can break these apart. So they get broken apart into their ions. Ions being their charged version, charged particles. Sodium has a plus charge because it's a metal. Carbonate has a 2- charge, it's a nonmetal. So in water, these will split apart. So now we've seen multiple ways to represent the solubility of these two salts. So again, in my test tube here, I've got nickel ions all floating around and sulfate ions all floating around. And in my other test tube, I've got carbonate ions floating around and sodium ions floating around. They're all separate from each other. Because they're all separate from each other, that means that they can rearrange, because that's what a chemical reaction is, the rearranging of atoms or molecules into different substances. Right now they're separate, so they can't rearrange. But if I were to mix them together, there's the potential for these to rearrange into different bonds. There's only 2 things that can possibly be made. The reason there's only 2 things that can possibly be made is because pluses can only bond to negatives, and negatives can only bond to positives. So if I were to mix these 2 test tubes together, the possibility is I could make nickel carbonate and sodium sulfate, or they just stay dissolved and unbound. It depends on if there's a strong attraction between any of these ions. If there's a very strong attraction between any of these ions, it might form an insoluble salt. So let's see what that would look like. If an insoluble salt is formed, it'll no longer be clear. It'll be really cloudy because a salt is forming. And I can do that by mixing these two things together. And we see immediately it makes this very cloudy salt. And I can mix this and centrifuge it, and then we can hypothesize about what this insoluble salt is. So I've spun my salt down here, and you can see I've got a liquid, and then this salt here. This salt cannot dissolve in the water. It's an insoluble salt. So let's look at what that means in terms of the Legos. So again, originally, I had nickel sulfate and sodium carbonate. I put them into water separately, and they split apart into their ions. Then I mix them together, and a salt formed. So I'm going to write this chemical formula with all of the ions separate. So I took nickel ions. Those are dissolved in water, so they're AQ. And sulfate ions. And sodium ions. Again, all dissolved in water. And carbonate ions. All dissolved in water. Because all the ions are separated, they can rearrange and make other compounds. If they do not separate, there's no way to make other compounds. They're already bound up. So we started with nickel sulfate and sodium carbonate. The only other options to be made would be nickel carbonate and sodium sulfate. So again, we have our Lego pieces here. We started with these together. There's only one way to rearrange this because positives can only bond to negatives. They switch. I can make nickel carbonate and sodium sulfate. So the question is, which is the insoluble salt? What's this green looking salt and what's in the liquid? The answer to this can be found on your periodic table. If you look at your solubility chart, we can look at the solubility of sodium sulfate. That's a yes. That means it is soluble. Meaning this one, sodium sulfate, will not look like this in solution. It will instead be split apart because it's soluble. Its ions will be separated in water. On the other hand, nickel and carbonate are a no, meaning that it will not dissolve in water. That means that this nickel and this carbonate bound together and they will not separate. And we can see that here. They're all together in a salt that we can see with our eyeballs. I could pour off this liquid and this would be a salt. It won't dissolve in water. If it did dissolve in water, it wouldn't look like this. It would be clear. It would be transparent. It would have color, but it would be transparent. This is not. You can see it. That's an insoluble salt, meaning it looks like a giant lattice of all these nickel carbonates all attracted to each other all together. That's why we can see it with our eyeballs, because it's bound together. The sodium sulfate is here in the liquid. It's in solution. It's separated. That's why this liquid up here looks see-through and colorless. So let's look at an insoluble salt on IC 2020. The reaction that we did created an insoluble salt. So here are the ions of the insoluble salt, and if I start them, they will all find a way to each other, making a lattice. This lattice is something you can see with your eyeballs. When you can see a salt with your eyeballs, that means there are many, many pluses and minuses all attracted to each other, all stuck together. So the difference between my soluble salt and my insoluble salt is that no matter how much water I put in here, it won't break it apart. That thing stays together no matter what. So I can put a bunch of water in. It stays as one lattice, one chunk, one whole compound all together, one crystal. Unlike my soluble salt, where when I put water in, it all broke apart. All the pluses and minuses broke apart from each other. And my insoluble salt, they stay together.